Welcome back, and welcome back to my channel. And today we'll be having a good presentation on inputs and outputs in computer architecture. So we are going to get right into it. So input and output refers to the communication between a computer and external devices, and it enables them to receive data and send data as well. So I'm sure you all know this by now that input and output communicate together to send and receive data. Yeah. And some of the examples are, for the inputs are keyboard, mouse, scanner. You have a lot more examples, and the output you have monitor, printer, and many more. And for the output we have hard disks and network interface card. So the next thing we are going to be talking about is input output system components. So the devices, we have the physical peripherals, that's the printer, the keyboard. You can also say mouse, controller, and many other stuffs. This manages communication between the device and the CPU, and it converts device specific signals to system compatible formats. The system bus, we also have something that's called the system bus, and with this it transfers data among CPU, memory, and the I/O devices, and it consists of the data bus, address bus, and the control bus. And over here we have the techniques for the input and output. We have the programmed. With that one, the CPU handles all operations. It constantly checks if device is ready or is polling, and it's insufficient due to busy waiting. We also have the interrupt driven IO, and with this device it interrupts CPU when it's ready. CPU executes other tasks while waiting, and it's more efficient than polling. And we also have the direct memory access, and that's with that one the devices communicates directly with memory and frees up CPU during data transfer, and it's ideal for large or high speed transfers. So here we have the comparison between the three techniques we just explained at the last slide. So for the programmed, you can see some of the features. The CPU involvement is very high for the programmed, but for the DMA is very low, and for the interrupts it's medium. And the efficiency is opposite of what we read for the CPU involvement. The program is low. For the programmed is low. For the interrupt is medium, and for the DMA is high. CPU waiting time. So with the program, the CPU, when the CPU is waiting, it blocks. It doesn't execute functions. And with the interrupts, it's non-blocking. It still executes. And with the DMA, it executes, but then it blocks at a minimal rate. And then the ideal use case for programmed I/O is used for simple devices. So maybe your phones, tablets, and other stuff. And then the interrupt I/O is used for moderate speed devices, and the DMA is also used for high speed or bulk transfers. And we also have the addressing methods. So we have the memory mapped. So devices share the same address space as memory, and it has a standard load store instruction used. For the port mapped isolated I/O, it separates address space for devices, and it requires special instructions, example in and out, and it's common in x86 architectures. The I/O performance metrics. So we'll be talking about the latency, throughput, bandwidth, and the goal of all this. So with the latency for the metrics, time delay before the transfer begins. That's what we used to measure. So with performance metrics, what it means is, what we use to measure for the latency is the time delay before the transfer begins, and for the throughput, the amount of data transferred per unit time, and for bandwidth, maximum possible data rate of the I/O path. So with the throughput, this is what you use to measure its performance in any input output device, and the same for the bandwidth. And the goal for the latency is to minimize latency and maximize throughput and bandwidth. So latency is, you can pretty much link it up to not glitching, but slow. It's a bit slow. It's not that fast. It doesn't have a high speed performance, and with the throughput and bandwidth, better reception and other stuff like that. And example of the the workflow, the file read from disk. So the user initiates a file read operation. The operating system sends requests to disk controller. The disk receives the data and uses the DMA to transfer to memory. And the device sends interrupts to CPU when data is ready. So if you remember, before we got here, we explained that we have the different techniques for we have the different techniques, that's the DMA and the program and the interrupt. So you can see here that two of them are working together. That's the interrupt and the DMA. So this is a summary of all we just learned, and that's the input and the output allows the system to interact with external hardware. Efficient input-output mechanisms improve overall system performance. We have for the techniques we've already mentioned: the program, interrupt driven, and the DME. The addressing modes: memory mapped input output and port mapped input output. Thank you very much for coming to my channel today and staying with us throughout the whole session. These are the group members of our group, and we all contributed together efficiently to bring you up to date news on the inputs outputs in computer architecture. And we hope you have a nice day. Thank you very much.